Sophie Line here, welcome back to my channel. This is another one of my favorites for our Aviation Adventure series here at Pima Air and Space Museum. This is an incredible collection. It's one of the most expansive I've ever seen. It's right off of Highway 10, which you can probably hear behind me. The first thing you see when you drive up are this massive collection of fixed-wing bombers and fighter aircraft that's visible right from the highway. But something else that they have is an awesome collection of rotary wing aircraft. So of course, if you know me, and by now you probably do, you know I'm going to find the biggest, lumpiest thing in the entire collection and become obsessed with it for a feature. So here's our CH-37 Mojave. It's an awesome condition. And we're gonna go inside and out today with our subject matter expert that I'm gonna introduce. And he's gonna take us through this big lumpy buddy. I'll turn the camera over to him and we'll begin. Come on.
Hi, I'm Jack McCain. I'm a reserve naval aviator. I've been flying since about 2009. My experience spans, I don't quite know how many airframes, about 2,000 hours, all said and done. Most of that was in rotary wing aircraft. MH-60 Sierra was my primary platform. I also flew the H-60 Alpha. I started my career flying search and rescue in Guam, then moved on to fly the UH-60 Alpha for the Afghan Air Force, Kandahar and Helmand, which was a really good time. And then after that, I graduated on to HSC-85, the Naval Special Warfare Helicopter Squadron, whose shirt I am adorned with today, and then finished my career flying for them last year. So this is one of my favorite helicopters of all time. A, because it's big, B, because it's weird. But it's also Sikorsky's first heavy lift helicopter, which is why it's so interesting. It's piston powered. We'll go in a little bit later as to why that's interesting and also problematic. But at the end of the day, the US military has to move big things all the time. And this was their attempt first for the United States Marine Corps and then later for the US Army, and one-off for the US Navy, which I'll talk about as well. But the heavy lift concept was to move, in this case, 26 combat loaded troops or a howitzer or 3 of these little micro jeeps they had from either a ship for an amphibious landing to wherever they're going, or from point A to point B. This aircraft served as the heavy lift cargo aircraft, but also it served a very specific role in Vietnam. With the Marines, they'd move cargo, ass and trash, as the colloquialism goes, but it found a niche in the recovery of downed aircraft and equipment in hard to reach places. If a Huey, for instance, crashed in a rice paddy somewhere, they would send this aircraft to go pick it up. It wasn't super effective in the combat logistics role because you can see by its size, it makes a very inviting target. The last thing you want to do is be sitting in this thing in an LZ that suddenly goes hot. So in Vietnam, for the Marine Corps, these aircraft flew under the call sign Junkman. Military call signs are really important. You have 2 different types. You have the call sign for the radio, and then you have the call sign for the person, mine being Whopper. But the call sign that you fly under is the radio call sign that you use when you talk to other aircraft or air traffic control. And Junkman, because they moved junk, I've flown under the call sign Night Rider, Brut, which means mustache, and under Firehawk as well as a few others. But it's something that you can tie your identity to, and the lore of your unit gets attached to those call signs as well. Some of the things you notice as you start to walk around it is this giant bulbous nose. This is the feature everybody notices because it's dead up front and it's frankly pretty silly looking. What this is the cargo door system. You had a hatch here that splits open and a hydraulic actuator that opens up the ramp and the clamshell doors from the inside. Some things to notice about this. This design is really the only aircraft rotary wing that had this for a whole bunch of reasons. The biggest one being is if the latches or the system were to fail mid-flight and you were at a high airspeed, then this turns into a giant sail, and that would be a very, very bad day. So it was a short-lived, if really interesting and funny design. There are stories also of the Marines in Vietnam using these front windows as gun ports to provide their own fire support. So above me here, you've got the cockpit or the flight deck. This is where you had 2 pilots sitting up front. It was accessed via a foldable ladder from inside the cabin, or outside you see the steps that you could climb up to or out of to get into the cockpit. So this was the first large aircraft with an automatic stabilization system provided in. This was originally only for the Marine Corps, not for the Army version, so it may not have been installed on this one. But what you had was an ability to hold your attitude, so just basically the nose angle of the aircraft, and your heading. What it enabled this aircraft to do was for it to be the first instrument-capable helicopter for the United States military. Instruments basically meaning that you can fly without visual reference outside the aircraft, which is really important for shipboard operations because you're not always able to recover in good weather or good visibility. However, as neat and interesting as the automatic stabilization system was, you did have some notable issues, biggest being unreliability. And when you're relying on automatic stabilization to keep you from careening into the ground, and that system fails, it becomes an exceedingly bad day up front and increases pilot workload. It's not impossible to land, but it does become a very complicated emergency for you to deal with if the system fails. But it was a first, and it was really the initial generation of instrument-capable helicopters for the US military, the same thing we do now. A couple things you'll notice here, obviously the bulbous aircraft, is the engine nacelle. First things first, the aircraft had retractable landing gear. So when they flew, this whole strut would fold up into the engine nacelle. That enabled it to have higher airspeed, but it added weight and complexity. As with everything in aircraft, there's always a trade-off between what you want the aircraft to do, what systems you want to have in it, and what weight you add to it. And speaking of weight, you can see this giant nacelle. Inside is a Pratt & Whitney R2800 radial engine. That's just about 46 liters of engine, which is massive. It's an 18-cylinder engine. Now, this engine was in the Corsair. This engine was in the F6F Hellcat. It was really popular during World War II as an aircraft engine. So because they had so many of them, they installed it into this helicopter. Now, they each had about 2,100 horsepower, and that sounds like a lot. 2,100 horsepower is a huge amount, so that gives it 4,200 horsepower between both engines. However, they were also incredibly heavy and very complex when compared to what we have now with your modern turboshaft engines. So, issue is they eat a lot of gas, they're extremely heavy, and they're hard to cool because they don't have a radiator attached. They're air-cooled engines. So if you're in a hover, first you're demanding an incredible amount of power from the engine, and you're not having a ton of forward airflow, which means that the engine is not getting very cool. So yes, it did have a lot of power. However, at well over 2,000 pounds, this was an incredibly heavy engine. And so your power to weight ratio was less than 1-to-1, whereas your normal turboshaft engine is going to be 5 or 6-to-1 when it comes to horsepower. For context, modern UH-60 helicopter has about 1,900 horsepower at its highest setting and highest burn rate. Some other drawbacks associated with your piston engines. Unlike turboshaft or turbofan engines, which are basically very simple, they're not very mechanically complex. This is an incredibly mechanically complex engine. And one of the things it does is has a tendency to seize. If the engine seizes, there is a clutch system. So the clutch system could disengage the engine from the rotor. So you're not trying to drive all that mass. But if it does seize, that means the engine's not spinning anymore. That is one of the biggest problems you can have in any helicopter, because the rotors, if they stop spinning, the aircraft has no glide ratio anymore, and you end up crashing and turning into a giant ball of fire on the ground, which is ill-advised. Other issues, its oil consumption, especially in the initial versions of this aircraft, was incredible. In fact, it burned almost as much oil as it did gas. And when it was at rest, because you have 18 seals for your oil system, it's just going to sit here and leak oil all day because it's not warm. The service life in a fixed wing application for these engines was about 2,000 hours before they either needed to be broken down for complete overhaul or replaced. In these aircraft, it was 350 hours because the engines were burned so hard and the power band that it was capable of operating in was just so limited that they basically had to run the engines at redline all the time, so that reduced the service life significantly. It also made a cacophonous noise when this thing was turned on. I cannot imagine how loud this thing was to be near, much less have your teeth and fillings shaken out of your head because of the vibrations from it. Okay, so another issue posed by radial engines, especially with this aircraft in particular, is there's a lot of moving parts, there's a lot of vibration. And you have two of them, as well as all of the other moving parts, like your transmissions, your gearboxes, your intermediate gearboxes, everything. So imagine an incredible amount of rotating metal. The radial engines produced an amazing amount of vibration. In fact, the vibrations were so bad that up in the cockpit, they did not mount the instrument panel to the airframe itself to help dampen it so that pilots could actually read the gauges. In order to fight these vibrations in the aircraft, they actually installed a vibration dampener in the nose later on in the service life of the aircraft. What's funny about this is while it did help dampen some of the vibrations, it had a tendency to explode and throw shrapnel all around the interior of the aircraft, which is really not ideal. So there's a good story of a pilot. They were in instrument conditions, which is probably the worst time for an emergency to happen because you can't see outside the aircraft. And they were trying to get down to the ground. The vibration dampener exploded, as it had the tendency to do, and the vibrations inside the aircraft were so bad that one of the pilots had to jam their feet against the instrument panel just so they could get enough of vision on the instruments themselves to be able to land safely, which is really not an ideal position. This is another advantage of turboshaft engines over piston engines like this, rotary engines in particular, is that there's a lot less vibration because there's a lot fewer moving parts. One of the other things you'll notice about this aircraft is you have these two, there's one on either side, 300-gallon drop tanks. They were installed. The internal fuel system for the aircraft is about 400 gallons. And so that's an incredible amount of fuel. However, in the research I've done, it says that they really didn't use these external fuel tanks very much for a couple of reasons. One, aircraft useful load was about 10,000 pounds, but that 10,000 pounds was at a very low fuel load. So if you started to add more equipment inside, about 26 troops for your 10,000 pound weight, the more equipment you add, then the less fuel you can carry, the less far you can go. So if you add more fuel with these extra fuel tanks, then you limit your ability to pick anything up. And an aircraft not moving anything really isn't a valuable aircraft to you. The other problem with these is apparently the external jettison system. In an emergency, if you lose an engine, which is pretty common in one of these, you want to have as little weight on the aircraft as possible. And so if you push the selector to dump this, if it doesn't go, then your emergency is now complicated. There's a story of one of these aircraft having an engine out. The pilot goes to push the jettison button. The aircraft does not jettison the external fuel tanks, and it took a ground maintenance crew a half hour after they landed to get this thing pulled off. So suffice to say, they didn't use it very often. So this aircraft is in US Army livery from Germany. So you see Ilsheim and you have that kind of Bavarian looking white and blue German stripes. Pretty neat, local livery is pretty cool. You had this side loading cargo door right here, opened up wide so that you could move cargo easily in and out when you weren't needing to use that front clamshell door. Now, one of the things you see in particular that you really notice about this aircraft, besides how gigantic it is the blades themselves are folded back. Now, every naval helicopter that we have in our inventory right now has a system similar to this, because space on board ships is at a premium at all times. So you want to have the ability to make the aircraft footprint as small as possible. This aircraft had a little bit of a reputation for being unreliable. A lot of that unreliability stemmed from this blade fold system. It was a hydraulic fold system that had a tendency to rupture and then spray hydraulic fluid all over the place. Hydraulic fluid is red, so it kind of looked like the aircraft was spouting blood. So the blade fold system was notorious. In fact, in Vietnam, when they brought the helicopters out there, they didn't mess with the blade fold at all. They'd lock it in place, service it as required, but they wouldn't fold the blades because folding the blades meant there was a probability for failure. You also see the hinged tail here. The Navy, you call this red gear. The clamps to hold the blades. We have a very similar thing on the UH-60. But you also see this hinge on the tail. It's a wet hinge, which means it's a hydraulic hinge. You have a hydraulic line right here. And this tail essentially folded all the way forward to, again, reduce the length of the aircraft and to make it a little smaller in height as well. Again, space on a ship deck or in a ship hangar is at a premium. So you always want to have the aircraft as small as possible. And you can tell this thing is gigantic. You had a single rear tail wheel here. From what I understand, later on in the design process, you ended up with a dual tail wheel on bogies. And you also see this upper tail surface, horizontal stabilizer is what it's called. On later versions, they had a stabilizer that was actually actuated. In a hover, it would be down, and then at cruise airspeed, it would come up, which essentially improved the handling characteristics at high speeds. The highest speed that this aircraft achieved in a clean configuration is 147 knots. For context, the fastest operational speed that you can get out of a UH-60 right now is 180 knots. So really a fast aircraft for its time, considering it was powered by piston engines. I know that Sophie hasn't had too many helicopters on her channel, so I'm going to explain just a little bit of the basics of how a helicopter works and functions. Most helicopters that we see today have this configuration with one large main rotor on top and then one tail rotor mounted on the side of the aircraft, whether in a tractor or a pusher configuration, this one being tractor. The purpose of the tail rotor is to keep the nose aligned and to provide anti-torque from the torque produced by the rotor head itself. So rotors in the United States move from right to left. In Europe, they go from left to right relative to the pilots. And Russia as well has the left to right, which means when you take off, you are going to have to add a little bit of either right or left pedal in order to counter the torque provided by the main rotors. So that's why you see the configuration like this. Inside the cockpit, you're going to see some different control systems. You'll see basically what looks like a stick, which would go between the pilot's legs. Just to the left, there's going to be another stick, which has a motorcycle twist grip as well as a couple other things on it. And then up top, you'll see a control quadrant that sits in between the pilots. So the cyclic, or the stick in between the pilot's legs, tilts the rotor disc to move the aircraft forward and back. The collective increases the pitch on the blades to basically bite more air, to add more power. And then the control quadrant up top controls, essentially you use it for starting the engines and then emergency operation. Now, what's so interesting about this aircraft, besides the fact that it's piston powered, is you control those piston engines from the top quadrant for starting and shutdown. But once you're flying, this collective has what's called a motorcycle twist grip, is essentially a fuel control system. Both engines are linked, and the pilot has to control the RPMs of the engine manually to make sure that your rotor speed is at 100%. All helicopters operate at a certain RPM that's most efficient. We call that 100% NR, and that's where the helicopter is happy at its steady state. If you get too low, then the helicopter will fall out of the sky. If you get too high, then you overspeed the rotors, and that can cause incredible damage. So wild to think that when you are flying this thing, both your feet are controlling essentially the rudder pedals of the tail rotor. Your hand is controlling the pitch of the direction the aircraft goes. Your left hand is controlling the up and down, as well as the engine. So it was a really complicated dance to be able to fly this thing effectively. Okay, so standing in front of this thing, you kind of get a sense that it looks a little ungainly. And yes, it's incredibly ungainly, especially when you look at it from a side profile. But what's amazing is this aircraft had an even more ungainly appearance in the form of the HR-2S TAC-1 Whiskey, which was the airborne early warning version of this aircraft. Essentially, its job was to act as a picket for the fleet. It would look down to see low-flying contacts coming in towards the bigger ships. Now, it had a giant plastic cover on the front of it, which basically was as wide as those nacelles, or nearly as wide as the nacelles, and it had a radar inside meant for look-down purposes. Now, it was not a very successful platform because, as we talked about, this aircraft had a notorious reputation for being incredibly vibrating. And so the radar really wouldn't work very long with the level of vibration it had. So it was not a successful platform, but it was flown by the United States Navy in that configuration. Okay, so internal to the cargo system, you have a cargo handling system inside the aircraft. It ran on a bar that ran the length of the interior, and you had a winch so that you could actually winch things into the aircraft. Big cargo aircraft and big cargo helicopters will have a winch to be able to pull cargo in because it helps alleviate some of the crew workload, suffice to say. Now, there are some great stories, one in particular that I connected with personally because I had a very similar experience. And in Vietnam, these aircraft would help move food, wounded, and then in some cases when they were servicing South Vietnamese troops, they'd move livestock. Reason for having livestock at a forward operating base is a lot of times you're not going to have refrigeration, and frankly the only way to keep the animal fresh at that time is to keep it alive. So when they moved livestock and when they moved food, you'd have these kind of standard rice bags inside the aircraft, and those rice bags are burlap, so they don't seal super well, and you'll end up with a little bit of rice inside the aircraft. Well, rice inside the aircraft, not super great. It makes it dirty, it gets wet and it'll rot, and being in the jungle, it's going to end up wet probably. And also, it's just bad for the maintenance of the aircraft. It'll get into hinges, mechanical things. You don't want that. So an enterprising crew chief came up with the idea, I'm assuming that he grew up on a farm, of using some of the livestock that they moved, chickens, free inside the aircraft to help pick up some of the rice. Pretty innovative idea, and it worked out great until they had the chickens on board and then cranked the helicopter, started the helicopter, and then the chickens got a little upset and ended up covering the inside of the aircraft with their own excrement. And if anybody's ever been around chickens, that's not a good smell. So try to solve one problem with a solution and you end up creating other problems. The reason I connect with it so much is when I was flying the 60 Alpha in Kandahar and Helmand for the Afghan military, I moved a significant amount of livestock, and we had all sorts of livestock handling issues, to include figuring out ways to keep the livestock from depositing their own excrement inside the helicopter. An interesting problem to solve, and the end of that story is for another time. So the one thing that you really notice about this aircraft is it feels really familiar. The reason being, this was Sikorsky's first heavy lift helicopter. And what it did was it informed the design language going forward of all of their other heavy lift helicopters to include the CH-53, which we have a brand new one, the CH-53 Kilo King Stallion, one of my favorites. So this design, you'll see a lot of things that are incredibly familiar. Some of the ones that didn't stick around, this front clamshell door, turns out that just a regular cargo ramp in the back is a lot more efficient for all sorts of reasons, to include being able to be opened during flight. Now, the Army version of this could open the clamshells in a hover, but it was not a good idea to do. This aircraft also had 5 rotor blades. You'll see there's a couple of other Sikorsky aircraft around that we'll take a quick look at, but the CH-53 has 7 rotor blades. The 5 rotor blades was so that if you had one shot away, you could still reliably fly the aircraft. Same design goes for the CH-53. There's some other aerodynamic considerations as to why you'd want that, but one of the major design influences was being able to shoot out one of the blades and still be able to fly. You'll also see this rear tailwheel configuration. For a large aircraft, that didn't stick around. The CH-53 has a front nose wheel as opposed to a rear tail wheel, but the Sikorsky UH-60 Alpha, or UH-60 version, except for the navalized versions, some of the navalized versions, has a tail dragger wheel just like this. When you want to put a cargo ramp on the aircraft, you can't have a tail wheel like that. You need to have one up front. An interesting thing that did not carry over in the design, and really hasn't carried over in much helicopter design, is the ability to pull your main landing gear in. The 53 Kilo does not have the ability to bring its landing gear inside. It doesn't have retractable landing gear. The consideration being its trade-off in weight, complexity, and maintenance cost. At the end of the day, with you pulling your landing gear in, you don't really gain that much in forward airspeed, and forward airspeed for a really large heavy helicopter isn't the main consideration. You want lifting capability. Now the 53 is incredibly fast because it does have 3 really big engines, and so it has a great forward airspeed. In fact, it'll outpace some of its much smaller competitors, but it doesn't have the ability to pull its main landing gear in because the drag associated with it, the penalty, is really not enough to warrant the complexity of bringing it in. Also, something that you don't see very much of in the design language of current contemporary helicopters is this pod design. The pod design was, this nacelle design was specific to this helicopter because you had the giant radial engines inside. And radial engines have a very large front surface area because they need to be cooled and the configuration demands it. So you don't see these outboard engines very much. This adds complexity to the drivetrain because you now have to transmit power from the pod all the way to the main rotor. And that's a lot of moving metal components that can fail. Another design language influence you'll see that really didn't get carried forward in helicopters is the separated flight deck from the cabin itself. You saw it with the H-19, and then you see it with this aircraft, but it didn't carry forward because having the crew separated doesn't really bode well for the crew concept, and as well, it's just a lot easier for the design. It was necessitated in this aircraft because you had the front clamshell, but really under any other circumstances, it's not necessary in modern helicopters. This is the MH-53, the Air Force Combat Rescue version and Special Operations version of the MH-53 that the Marine Corps has as well. Their design language is very similar because they come from Sikorsky and it serves the same mission, so it's going to look very familiar. The most obvious one being these external drop tanks. Now, these external drop tanks are a lot more useful than the ones that they had in the other aircraft. So, but it's just made to store more fuel so you can fly longer range. These aircraft have an incredible range and the jet assist system works unlike in the old aircraft. But if you really kind of pan around, it's going to look and feel very familiar, whether it's the odd number of blades up top, 7 in this case, 5 for the other aircraft. You see there's no more engine nacelles. You have 3 engines all on top, as opposed to the 2 piston engines. You have the tail rotor in the same configuration. So again, it's not the same, but it feels the same. Serves the same mission, same company, same ideas, just much more advanced. So that's the end of the major components that I'll give you today on the CH-37. But it was introduced, its first flight was in 1953. It had a very short design period. Initial stage 1950, first flew in 1953, was delivered to the United States Marine Corps in 1956. It served until the end of the 1960s, but because of the limitations, weight, complexity, poor reliability, and piston engines, it had a short service life. And unlike a lot of other former military helicopters, it didn't really go on to the civilian world the same way it did with some others. It did some heavy lift. There was one company that used them to move essentially telephone poles and other things around, but they're very expensive to maintain and they burn fuel very quickly. But its really notable piece is that it influenced how Sikorsky would design the rest of its heavy lift aircraft all the way up until today. The CH-53 Kilo is the newest heavy lift aircraft in the United States military, and it looks, feels, probably smells almost exactly the same as this aircraft. So a storied service life, not necessarily. An interesting one, absolutely. It found its niche in Vietnam, picking up downed aircraft and moving equipment around, but it helped bring the world that we see today forward.
Thank you so much for watching. It's an amazing privilege to be able to come here and to take some of your time and to spend with this incredible machine behind us, to sit in the shade of such a beast. This is an incredible museum with an amazing collection. It's actually really difficult as a creator to cover the expanse of the collection, not just how many aircraft they have, but the history that it spans. So come out here and check it out for yourself. The links to the museum, its website and its social media are down below, as well as the comprehensive list of the aircraft and the ordnance and everything that it has in its collection. So let me know what you'd like us to cover next, fixed wing, rotary wing, whatever. Drop it down into the comments and we'll see what we can do. And join us for our next video of our Summer of Aviation Adventures here at Pima Air and Space, and we'll see you next time.